This is chapter 5.1 on Introduction to Polynomials. This chapter is fairly weird in that you're starting off the gate kind of doing things that don't really make a whole lot of sense right now. But as we get deeper into the chapter, things start to come together. I just tell students to have the faith in this chapter because eventually things do make sense. So we start off with question 1, which says identify at least 3 mathematical words or phrases you could refer to the polynomial -5 plus 2x. So the first thing you could have said is it is a binomial. That's one thing. And what does that mean? You could have also said it has 2 terms. The terms are a -5 and an x squared. And again, to refresh your memory, terms are those parts of an expression that are connected by plus or minus. Technically, they are referring to different powers, different combinations of exponents, or as a constant. You could also say that -5 is the constant, and a constant really means is a term in an expression that does not have a variable associated with it, so it's a plus or minus value. So in this particular expression, this is a binomial with a constant of -5. And some people who learn this in algebra in grade 7 or 8 remember that the constant usually is the second term in an expression, but it doesn't always have to be the second term. It could be the first term. As a variable of x, it also has an exponent of 2. And that's about all of the ones I could probably say about it. Those are the 5 words you probably used in describing that binomial. Noah is very smart. He could have also said it's a polynomial. Even though it's a binomial, we could have said polynomial. And that the term has a degree of 2. And the entire polynomial, or the entire binomial, also has a degree of 2. Because polynomials, the degree of an entire polynomial, whether it has 1 term, 2 terms, 10 terms, the entire degree of the polynomial is defined by the degree of that polynomial's highest term. So in this case, the exponent of 2 defines the degree of that, and therefore it is the degree of 2. Question 3 says, give 2 examples of a polynomial that satisfies all statements. Consists of 2 terms, so we need a binomial. Contains 2 variables. Now this is kind of weird because people think an x squared and x can be 2 different variables. I think it probably means x and y, but since we've never used 2 variables in anything we've ever done up until now, it seems weird to ask that, but we'll try it anyway. Has a degree of 2, and 1 term is of degree 1 and has a coefficient of 1. So let's try this first. So let's go with x squared minus y. Let's just try this one first. Does it have 2 terms? Yes, it does. It has an x squared and it has a y. Does it contain 2 variables? Yes, it does. Does this particular binomial have a degree of 2? Yes, it does, because the x squared has a 2, the y has a 1, therefore the entire polynomial has a degree of 1. 1 term is of a degree 1. Well, this term here, y, has a degree of 1, and has a coefficient of 1. Uh-oh. This is tricky. Does anyone know what the coefficient is for this one? It looks like a 1, but it's not. It's a -1, so therefore we have to make that an addition symbol. Now it's a coefficient of 1, right? It's a positive 1y, not a negative 1y. And that would be one that works. And there are a whole bunch of different examples, and rather than give you a whole bunch of different ones, we'll just leave it at that. You could have had 4xy plus, what do we have here? Plus z. Does this work? 2 terms? Yes. 2 variables? Oops. Nope, it has 3 variables, so we can't do that one. Anyone have another example just before I go on to the next one? Does anyone have a different one besides this? Nobody? Perfect. Off we go. Question 4. When is it acceptable not to write the 1 in an algebraic expression. You must, and when must you write the 1? Give examples. So you don't need to use a 1 when it's a coefficient of 1. So for example, if it's 1x, we just say x. We don't say 1x, we just say x. And if it's exponent of 1, we don't really define it as being exponent of 1. We just simply say just x. So the two times you don't need to write a 1 is as a coefficient or as an exponent. I can't write today. Coefficient or exponent. When do you need it? You need to write a 1 if it is a constant term. So like a plus 1 or a minus 1. Question 5. For each expression, identify the number of terms and whether the expression is a monomial, binomial, trinomial, or polynomial. So the first one here has 1 term, 2 terms, and 3 terms. And we know those are terms because they're connected with addition or subtraction symbols. And they are unique in that they have unique either variables, either an x squared, or x cubed, or an x, or an xy, or a y. They are different in terms of the variable configuration, or they are just a constant term. So those are 3 terms right there in this one. It makes it a trinomial. One more. B has 1 term, and it's a monomial. This third one, C, has 1, 2, 3, 4 terms, which makes it a polynomial. And the last term, 8, is just the number 8, or sorry, D is just the number 8. It's just a constant, which makes it a monomial because there's just 1 term. Now, it doesn't say to describe the degree, but let's just do it real quick anyway. This one, because this term has a degree of 2, this term has a degree of 1. The entire polynomial here has a degree of 2. This one would have a degree of 1 because the exponent on the a is a 1, even though it's not written. This one has a degree of 2, because C and F both have 1. D and F both have 1, and F has 2. So the degree of the entire polynomial, since there's 4 terms, is still 2, because of those 4 terms, the highest degree is 2. And 8, being a constant with no variable, has a degree of 0, because in order for the exponent to count towards its degree, it must be attached to a variable, a term with a variable. Question 6, what's the number of terms and what is the name for each expression? This is a 1 term, and it's called a monomial. This is a 3 term, called a trinomial. This is a 0 term, Z-E-R-O, 0 term, and it's called a monomial. Sorry, it's a 1 term. Oh, not 0 term. Why did I say that? It's a 1 term, because it's a 0. It's a monomial. This is a 2 term, and it's called a binomial. Binomial. Question 8, for each polynomial, what is the degree and number of terms? Oh my God, it's redundant here. 2 terms, degree of 1, because the b has an exponent of 1 that's not written. Fg plus 2g, well, Fg is f multiplied by g. And each of these variables has an exponent of 1. So Fg is 1 term, because it's not connected with addition, rather multiplication. So this has a degree of 2. This g has an exponent of 1, so it has a degree of 1. So we would say that Fg plus 2g is a binomial and has a degree of 2 because Fg is its highest term. And finally, C, it's a trinomial, and the degree of it, this has a degree of 2. This has a degree of 2, even though it doesn't look like it. This has a degree of 2. So the entire trinomial has a degree of 2 as well. Your next question, question 10, says refer to the polynomials below to answer your question. Which ones are binomials? So binomials meaning, of course, bicycle, 2 tires, 2 terms. This one here and this one here would be binomials. Which ones have degrees of 2? Question B. This one only has 1 term, and it only has 1 variable, b, and the exponent on that variable is 2. So therefore, the first one, the monomial, has a degree of 2. This p has an exponent of 1, so therefore it does not have a degree of 2, it has a degree of 1. This one looks like it doesn't have a degree of 2, but the st term, the 4 multiplied by s multiplied by t, each of those variables in that term have hidden exponents of 1, which makes that term 4st have a degree of 2. The second term, t, has a degree of 1, and then there's a constant of minus 1. So it has a degree of 2 as well. And finally, the last one, 2x squared, this has a degree of 2. This has a degree of 2. So this one also has a degree of 2. So every expression there except for the second one has degrees of 2. C, what is the variable in the monomial? So the monomial is here. So you first had to identify that. And the variable in there is b. So what is the variable in the monomial? The answer is b. And finally, your last one, which polynomials have a constant term? Remember, a constant term is a term that does not have a variable, just a number. So therefore, this one does, because this term here is a constant, and this trinomial has a constant of minus 1. Your next question, 11, says what is the expression represented in each of these algebra tiles? Now remember, these are x tiles, and because they're shaded in, they're positive x, and these are -1 integer chips, or -1 tiles, algebra tiles. So therefore, you have 2 x's and -3 for your first one. This is an x squared tile. This is a -x and a -x, and this is a positive 1. So you have 1x squared. Now you don't write coefficients of 1. I think we talked about that already. So just a x squared tile, or 1x squared tile, minus 2x squared tiles, plus 1. So this picture here represents the trinomial x squared minus 2x plus 1. And finally, this one. Hey, and your last question, this is a positive x squared because it's shaded in. And just like algebra chips, if it's not, or algebra integer chips, if it's empty, it's considered negative. So it's a negative x squared and a positive 3x and a negative 2. So we have negative x squared plus 3x minus 2. Now, just as an extension question, if I gave you a D and I gave you this, and this, and this, and this, let's just say I gave you this question and said, what is this polynomial? Well, this one here is your negative x squared, and it is the term of the 3 that you see there that has the highest degree. So when I was to rewrite it, I would put that one first, then I would put my 2 x's, then I would put my 3. Even though this is the first thing I see in the picture, I still have to kind of reorganize my algebra tiles according to the degree of the term, and I would put my x squared tiles first in my polynomial as an extension. And finally, the last question, 13 and 14, says model each polynomial. So the first one would be an x squared tile, and an x tile, and a minus 1 tile. That is x squared plus x minus 1. 3x plus 2 would be an x tile, and an x tile, and an x tile, and a plus 2. And your negative 2x's would be an open x tile and an open x tile for negative 2x. And finally, your last question, use a model to represent each polynomial. A negative x squared is a negative open x squared tiled, plus 3. And I know I'm using integer chips here for the plus 3 instead of the small little boxes shaded in. I suppose that's a better one, but it's just too hard for me to draw, so I'm just going to use integer chips instead. 2x squared would be an x squared tile and another x squared tile to show 2 x squared tiles. And a minus 3x would be 3 negative x tiles to make negative 3x. And finally, your 8 is just 8 integer chips, or 8 small little square shaded in algebra tiles.